In the video you're about to watch, we're going to be sketching the more complex quadratic graphs using transformations, and we're dealing with quadratics where the equation is in turning point form. So this video will in part rely on a worked example to show, and the worked example is sketch by hand, so not using technology and just copying it down. Sketch by hand, which shows that we need to basically use our knowledge of transformations, and we're going to do that one, and it is a little bit probably at this stage a little bit harder than some of the ones you might have seen. So this video assumes you've already seen the turning point form of a quadratic, and we can use that to help us sketch parabolas. We've got parameter A, H and K, and this relies on your knowledge of that. So going back a little bit, the basic parabola is y equals x squared, and you can see that on your screen now. And you can see that I've got Desmos with some slider bars on, and if you look at what A is set at, it's 1, H is set at 0, so in the brackets it'd be x minus 0, which should just be x, and then that's squared, so all we have is x squared. Plus k, but k is set at 0, so it's plus 0. So all we have is y equals 1x squared, or just y equals x squared. And you know that already, that's what the parabola will look like. And you've seen in the past, or if you haven't seen in the past, you're watching the wrong video, but basically A is a dilation, a shape changer. If A is between 0 and 1, not inclusive, we have a broader, squished down, compressed, negative, well, not negatively, but we're dilated by less than a factor of 1. So it's a less sharp, blunter parabola. If it's greater than 1, it's a sharper parabola, because the values on either side of 0 zoom up for y. If we go below 0, i.e. negative, we get a reflection. So we've seen that before, and we've also seen that h, if we set it up in h minus, or the minus form, minus h, as we increase h, it'll move to the right, translate to the left if it's less than 0. So as you can see there, it's set at h equals negative 3 at the moment. So that in there, that would be x minus negative 3, which is x plus 3. So it would be x plus 3 all squared. So that is a left to right translation, and this one is a vertical translation, the number of units that k is. So k is positive 3, so it's moved up 3 from its original point, which was down there. Move down if k is negative. Okay, so it's a bit of revision. Now you can see up the top left of your screen we have y equals 1 minus 2 outside of x plus 2 all squared, which is the same as what we had over here. Okay, 1 minus 2 outside of x plus 2 all squared, and to get that we've got to look at what A is. Now this one here has the constant sitting on the front. Now that's actually the k value. Alright, and the k value is 1, it's positive 1, but it's sitting at the front. Now, because that's a plus sign there, you can change the order around, and it's actually written on the front of this one. So we've got to set k equal to 1, so you can see that it's getting adjusted to 1 there. We then move on to this 2, that's actually the A value. A is, now what is A? A is actually negative 2, because you can see the minus sign there. Alright, so we've got to set A to negative 2. So that will be a reflection in the y-axis. Okay, and inside we have plus 2. Now, to get a plus there, we have to minus a negative. So we have to have H as negative 2. We need to know that, whether we use technology or not, we need to know that before we sketch it. So we need our knowledge of transformations of using parameters A, H and K. We need that to be in good shape before we commence work. And just to show you that it's right, okay, it sits right on top of the given equation there. So that works well. See, so they're one and the same. Okay, so let's see how we sketch that now. So we start by looking at our set of axes for x and y and coming up with a reasonable scale. Now I'm using a different scale on the x and y axes. You can see the blue marks, the blue lines. I'm using 1 increment per 1 unit on the x-axis, but I'm using half increments here on the y-axis. So that's going up 1, 2, 3, 4, 5, like that. This is going 1, 2, 3. So it's not the same scale, because my experience with quadratics, once you square something, it can make the y values larger than you might expect at first. Now there's a few ways of thinking this through. If we look at our knowledge of parabolas so far, we know that h and k are translations sideways and up and down. We also know from our previous work that h comma k is the turning point, which I'll just call TP. And if it's in x minus h form, as we said before, that would mean that h would have to be -2. K, as we said just before, is sitting on the front and it's +1. So the turning point will be at -2, 1. So I'm going to go -2 and 1, which will be there. That'll be our turning point we'll use in a minute. We also know that if we have a y-intercept, x equals 0, y-intercept is when x equals 0. So we sub 0 into this equation for x. So that would be y equals 1 minus 2 outside of 0 plus 2, which is 2. We square that. We have 1 minus 2 times 4. And we have 1 minus 8, which is -7. So the intercept, the y-intercept, is at 0, -7. Okay, so I'll write that in. 0, -7. So going down here, 1, 2, 3, 4, 5, 6, 7, there. Okay, so we know that because it's got an a is -2, it's going to be reflected and dilated by a factor of 2. We're going to deal with that first, so deal with shape first. Okay, shape is usually the best thing to deal with first, position second. So A is to do with shape, and H and K are to do with the position of all the points. So we need to remember that it's going to be reflected and dilated by a factor of 2. Then we looked at H and K were -2 and 1. It's going to be translated sideways. Now we just saw that H, which is your sideways translation, okay, now it'll be moved to the left too, because it's a negative. So 2 to the left, and K was 1, so it's going to be translated up 1 unit. So 2 units to the left and up 1. So where do we start? We start with our base parabola, like we just looked at. So we've got our base parabola, and we basically have, when we have y equals x squared, okay, so that's y equals x squared in red. So when x is 1, y is 1. When x is 2, y is 4. X is -2, y is also 4. 3 and 9, 1, 2, 2, 4, 6, 8, 2, 4, 6, 8, 9. Alright, 2, 4, 6, 8, 9, and so on. Don't go too crazy there, it's just a rough sketch. Okay, so it might be handy to look at an in-between step. So we want to head to what -2 for A. I'm going to put in an even easier step there, 2x squared. So that means it's going to be like that. It's going to be dilated. It's going to be by a factor of 2. And then to get -2x squared, that then is going to be reflected. So it's reflected in the x-axis. So that orange one is going to be reflected, so it's going to be like that. Now we need to put in our translation. So I said shape first. We've got the basic shape, that's the pink. Alright, it's a rough shape. The position is the second thing. So we're going to look at H and K, and just a moment ago we said it's 2 to the left and up 1. We've also got those 2 blue guide points, so we know it's going to be a sad parabola, and it's going to be moved 2 to the left and up 1. Now that's good, because if we look at this point here, if we move it 2 to the left and up 1, it does match that point that we found out before. Alright, we need to try and keep the shape the same, and so the final one I'm going to put in dark blue, so that will be y equals -2 x plus, it was x plus 2 all squared, plus 1. Now you might think, hey Mr. Herbert, you've changed the equation. No, I haven't. I've just put the plus 1 on the end. Okay, so what we do is we need to move all the points 2 to the left and up 1. We also have another guide point. We said before that it has a y-intercept, so make use of that. So we have the turning point, the y-intercept, and the basic shape. And so it's only a sketch. It's going to go like that. We keep retaining that basic shape, and so on like that. Ooh, mine looks like a bent paperclip. Sorry, it needs to be curvier than that. There we go. And that's basically it there. Okay, so we've been through a few steps. That's a more difficult one. Just confirming the answer with technology there. We see it does go through that y-intercept, and it does turn around there. In a future video, we're going to be looking at these x-intercepts and using a different method to sketch them. Try some.